Okay, here we go. We are at quarter 3, week 5, day 4. We are going to find the quotient again. All right, so they really like this because they want to make us do that extra step. If that was a multiplication sign, we would just multiply straight across. But since it's division, keep, change, flip. So we're going to keep the 1/4. We're going to change the division sign to a multiplication sign, and then we're going to flip this into the multiplicative inverse, or the I cannot think of the other one, or the inverse, right? Multiplicative inverse, or the reciprocal is what I was trying to think of. So 1 times 5 is 5, and then 4 times 3 is 12. 5 over 12, can't reduce it. There's our answer. All right, that's all we have to do for that one. A factory worker can make 14 products in 45 minutes. What is the worker's unit rate? Which means how much time does it take for one product? Okay, so how many minutes for one product? Well, I've made something like this to see if I can just do it simply without having to do much calculations. And I know that half of 14 is 7. And I know that half of 45 is actually 22, because I know 22 is half of 44.5. But that still doesn't get us to our unit rate. So to get down to 1, okay, I can either do 14 divided by 14 to get 1, and then 45 divided by 14. Or I could do 7 divided by 7, and then do 22.5 divided by 7. But regardless, let's just say we're doing the 14. 14 divided by 14 will give us 1. So then we do 45 divided by 14, and that's going to give us 3.214. Okay, so basically here's our unit rate. It's going to take 3.214 minutes per product. All right, and that's how we find the unit rate. We just scale this down so that it is a 1. All right, that's all you have to do. Write an equivalent expression for 36x plus 12. Well, I kind of looked over here and I took all of the factors of 36, all the factors of 12, and I thought, wow, you can take 12 out of both 36 and 12. Look, right here, there's a 12 on this side, and there's a 12 on this side. So what we're going to do is we're going to take 12 and factor it out. Okay, 12 goes into 36 3 times, so that's going to become 3x. And 12 goes into 12 once. Okay, so there's an equivalent expression. But I do want to point out that since there are other common factors like the 6 and the 4 and the 3 and the 2, we had lots of options here. If we factored out the 12, then this would be the answer. If we factored out the 6, then 6 times 6 is 36, and so on. Or we could have used the 4 or the 3 or the 2. Okay, any of these would actually have been just fine because they would all be equivalent expressions. Typically, you use the largest number, okay, the greatest common factor, okay, but you don't always have to if all they're doing is asking you to find an equivalent expression. Draw a number line to represent the inequality. Okay, so we have y is less than 3. So why would I put the 3 right here in the middle? Because, well, that's what we're comparing everything to. We're deciding, are they going to be bigger than 3 or less than 3? And we literally just kind of said it out loud. Now, one thing that you might notice, and I kind of put an underline there, which I shouldn't have done. Okay, so it says y is less than 3, right? Does it say y is less than or equal to 3? No, it does not have the little line there. It doesn't have that. Okay, so that means we're going to put a circle right there on the number line, but we're not going to color it in because we're not going to include the 3. Now let's say this one more time. Y is less than 3. So what numbers are less than 3? The ones to the right, is 4 and 5 less than 3, or is 1 and 2 less than 3? Well, obviously, it's going to be any number that is to the left, right? Because in the number line, any number left of the number is less than. Any number to the right is more than. So y is less than 3. So it can be 2, 1, 0. It could be negative a million. Okay, that's our answer. And remember, make sure that you keep this not colored in. A smaller square is located inside of a larger square. Okay, that's what we have right here. The length of the smaller square is 7 centimeters. Well, it's a square, so you know that every side is the same. Every side is 7 centimeters. And the length of the larger square is 12 centimeters. Once again, every side is going to be 12. Find the area of the section outside the small square but inside the large square. Okay, so we're basically trying to find the area inside here, right? So basically I have the square that doesn't have a square inside of it over here, and that whole thing is 12 by 12 by 12. So remember, base times height is the area of the square. So 12 times 12 is 144. So the bigger square is 144 centimeters squared. And then we have the smaller square inside here that we have to cut out, okay? And so that's going to be 7 by 7. And of course, 7 times 7 is 49. So this was the area of the bigger square. We're cutting out the area of the smaller square to find out this area here. Okay, so we're just going to subtract that. All right, so we're going to have to borrow from this 4, make it a 3. Okay, this makes it 14. And then we have 14 minus 9 equals 5. Then we can't take 4 away from 3, so we're going to have to borrow here. Then we have 13 minus 4, and that equals 9. Okay, so it turns out that the space in between the larger and the smaller square is 95 centimeters squared. Okay, so that's how we would find that one. We would find the area of the bigger one, the area of the smaller one, subtract it out, and that's going to give us this leftover space right here that's in between the two squares. So 95 centimeters squared. Andrea needs a box that has a volume of 90 cubic inches. And remember, volume is length times width times height. So it's going to have to be something times something times something. And that's going to have to equal 90. So the volume is 90. So you just have to have 3 numbers that equal 90. So I just made a drawing. And then if you put a 3 here and a 3 here, that's 3 times 3 is 9. Well, 9 times what will give you 90? And that would be 10. So one possibility is going to be 3 by 3 by 10. Okay, so that's probably the most reasonable one, because there are some other possibilities, like, you could do 1. Let's see. If we do, let me just erase this. If we do 1 by 3, but that would be a really odd shape. Let's say this is 1, this is 3. That's 3. 3 times what is 90? 30. So we'd have a box that's really be like a really thin box this way, 3 this way, and then extremely long this way, right? So we'd have a really strange looking box. All right, and then you could also do 2 by 1 by 15. Okay, those are all possibilities. But probably the most reasonable one is going to be the 3 by 3 by 10. Okay, that box, it would look a little more like that. So it would be 3 by 3 by 10. I think that's going to be the most reasonable one. All right, so anyway, there's our answer. So these are the measurements of the box to get 90 inches cubed. Find the surface area. So I drew in some little additional dashes to kind of see what it looks like if you could see through it. And then I also made a net over here. And it turns out the base is going to be 4 by 10. And then each one of the sides, this is also 4 by 10. And over here, another 4 by 10. So all 3 of the rectangles are 4 by 10. Well, what is 10 times 4? Well, it's 40, right? So each one of these is a 40. So now we just have to find out what is the area of the triangle. Well, the triangle has a base of 4 and a height of 3. The same thing with over here. So 4 times 3 is 12. Half of 12, because it's a triangle, is 6. So this becomes a 6 and a 6. So basically we know that 40 times 3, okay, is going to be 120. So that's the area of all of this so far. Then we just have to add 12 onto that. Well, 120 plus 12 is 132. So that's our total surface area, 132 inches squared. 132 inches squared is the surface area for this triangular prism. It is Jamie's birthday, and her mom just bought her an Xbox. She is trying to find the surface area of the box so she can determine how much wrapping paper to use. Okay, the box is 24 long, 12 wide, and 10 inches high. So I kind of did a little simulated drawing up here. What is the surface area of Jamie's new Xbox? Okay, so we need to find the front and the back. Well, the front and the back is right there. And that's going to be 10 times 12, which is 120. So the front is 120. So obviously the back is 120. Now let's try to find the sides. Well, the side is 24 by 10. Well, 24 and 10 is 240. So it's going to be 240 for one side, which means it's definitely going to be 240 for the other side. And then we have the top and the bottom. Well, the top and the bottom are 24 by 12. So 24 times 12 is 288. So that's going to be the top. And of course, if it's the top, it's also the bottom. So what are we going to do to find the total surface area? Well, we're going to have to add all of this up. Okay, so let's add all of this up. We have 8 plus 8 plus 0 plus 0 plus 8 plus 8 is 16, right? So we'll do that. Here's the 1. All right, let's see. We have 8 and 8, and we have 2 4s, which would be 8. So 8 times 3 is 24, plus 1 more is 25, 26, 27, 28, 29. So we have a 9 here. Put a 2 here. And we're just kind of counting by 2s. 2, 4, 6, 8, 10, plus 2 more is 12, or 10, 11, 12. Yeah, 12. So 1,296. So that's our answer. 1,296 inches squared. Inches squared. 1,296 inches squared is the surface area of the Xbox. Okay, so if she's going to wrap it up, she has to have enough wrapping paper to cover 1,296 squared inches for that wrapping. And that's all there is to that one.